Connected is crucial. We rely on the internet for everything. But have you ever stopped to consider how this connection is made possible, especially in remote corners of the world? It's all thanks to satellites. Among them, low Earth orbit satellites, or LEOs, are transforming the way we connect, powering the internet in places once considered unreachable. Imagine a world without the internet. For many, this is a reality. Millions lack access to reliable internet, especially in remote and underserved areas. LEOs are emerging as a powerful solution, beaming down internet signals from space to reach areas where traditional infrastructure is difficult or impossible to deploy. So what exactly are LEO satellites? These are relatively small satellites that orbit the Earth at much lower altitudes, typically between 180 to 2,000 kilometers. This proximity to Earth is key to their ability to deliver high-speed internet with low latency. LEOs travel at incredible speeds, completing an orbit around the Earth every 90 to 120 minutes. Despite their small size, often comparable to a refrigerator, LEO satellites are packed with powerful technology. To understand the power of LEO satellites, we must first grasp their position in space. Unlike geostationary satellites, which hover over a fixed point, LEOs operate much closer to Earth. This proximity ensures that data packets traverse a much shorter path, minimizing signal delays. This is crucial for latency-sensitive applications like video conferencing and online gaming. LEO satellites are technological marvels, packing an impressive array of instruments into compact packages. At the heart of an LEO satellite lies its communication payload, responsible for receiving and transmitting data. Powering these systems are large solar panels, converting sunlight into electricity. To maintain stability, LEOs rely on reaction wheels and propulsion systems. Despite their sophistication, LEO satellites face a constant battle against atmospheric drag, limiting their lifespan to 5 to 7 years. To mitigate space debris, defunct LEOs are carefully deorbited or moved to a graveyard orbit. Managing the growing number of LEOs is crucial for maintaining the sustainability of space operations. International cooperation and adherence to guidelines are paramount. In the realm of internet connectivity, speed is king. LEO satellites shine with their low latency, crucial for real-time communication and data-intensive applications. Their proximity to Earth translates into significantly shorter signal travel times. This near-instantaneous communication is a game-changer for applications like video conferencing and online gaming. Our reliance on the internet continues to grow, with data consumption reaching unprecedented levels. LEO satellites offer significantly higher bandwidth capabilities compared to traditional satellite internet solutions. This is due to their closer proximity to Earth and the use of higher frequency bands for communication. This abundance of bandwidth is crucial for delivering a seamless internet experience. LEO satellites provide global internet coverage, reaching even the most remote areas. Traditional infrastructure is often difficult and costly to deploy in challenging regions. LEOs transcend these limitations, forming interconnected networks known as constellations. This global reach empowers communities with access to educational resources, telemedicine services, and economic opportunities. While the advantages of LEO-powered internet are undeniable, challenges like space debris and short satellite lifespans exist. Addressing these challenges requires robust international regulations and responsible satellite design. Despite these hurdles, the potential benefits of LEO-powered internet are significant. As technology advances, we can overcome these challenges and unlock a future of ubiquitous connectivity. The digital age is defined by an insatiable appetite for data. LEOs offer a compelling solution, providing high-speed internet access from space. This growing demand is not limited to individuals, but extends to businesses, governments, and research institutions. The versatility of LEO satellites makes them an attractive solution for a multitude of sectors. Recent advancements in satellite technology, particularly miniaturization, have made mega-constellations feasible. Smaller satellites are significantly cheaper to launch and require less propellant. The rise of commercial space companies and reusable rockets has further reduced launch costs. This makes it more economically viable to deploy and maintain large satellite networks. Section 1. The Final Frontier. Responsible Stewardship of Space. Space, once considered an infinite frontier, is now a shared resource, teeming with human-made objects. As we launch more satellites to meet the growing demand for connectivity, we must recognize the importance of responsible space stewardship. Just as we strive to protect our oceans and forests, so too must we safeguard the orbital environment for current and future generations. This responsibility extends beyond simply launching satellites into orbit. It encompasses their entire life cycle, from design and deployment to their eventual decommissioning and disposal. International standards and guidelines play a crucial role in ensuring that space activities are conducted in a sustainable and responsible manner, minimizing their impact on the space environment and preserving its long-term viability. The consequences of neglecting this responsibility are significant. Uncontrolled proliferation of space debris resulting from collisions or improper disposal could lead to a cascade of impacts, rendering certain orbits unusable and jeopardizing the future of space exploration and utilization. Responsible space stewardship is not merely an option, it's an imperative. By adhering to international standards and embracing sustainable practices, we can ensure that space remains a valuable asset for humanity, supporting scientific discovery, technological innovation, and societal progress for generations to come. A satellite's finite journey. LEO satellites have a finite lifespan, typically 5 to 7 years. Managing this lifespan is crucial to prevent hazardous space debris. International guidelines provide a framework for responsible satellite disposal. Operators plan for deorbiting, using propulsion to re-enter Earth's atmosphere. This ensures satellites are safely removed, minimizing collision risks. Section 3. Debris mitigation, protecting the space environment. Space debris, often described as a silent threat, poses a significant challenge to the long-term sustainability of space activities. This debris, ranging from defunct satellites and spent rocket stages to fragments from collisions and even flecks of paint, can travel at incredible speeds, posing a collision hazard to operational satellites and spacecraft. International efforts to mitigate space debris focus on two key areas: prevention and remediation. Prevention involves minimizing the creation of new debris through responsible satellite design, operation, and disposal practices. This includes measures like shielding vulnerable components from micrometeoroid and debris impacts, implementing collision avoidance maneuvers, and deorbiting satellites at the end of their operational life. Remediation, on the other hand, involves developing technologies and strategies to remove existing debris from orbit. Concepts like active debris removal systems, which could capture and deorbit large debris objects, are being explored as potential solutions. The challenge of space debris requires a collaborative approach, with nations and space agencies working together to develop and implement effective mitigation strategies. By embracing a proactive approach to debris management, we can ensure a cleaner and safer space environment for future generations. Section 4. International collaboration, a shared responsibility. The challenges posed by space debris and the need for responsible satellite lifecycle management transcend national borders. Space, after all, is a global commons, belonging to all of humanity. Addressing these issues requires international cooperation, with nations working together to establish and uphold common standards and guidelines. Various international organizations play a crucial role in fostering this collaboration. The United Nations Committee on the Peaceful Uses of Outer Space, or COPUOS, provides a platform for nations to discuss and develop international space law and policy, including guidelines for space debris mitigation. The Interagency Space Debris Coordination Committee, or IADC, comprising space agencies from around the world, focuses on technical aspects of space debris mitigation. developing and sharing best practices for satellite design, operation, and disposal. International cooperation is not merely a desirable goal, it's an absolute necessity for ensuring the long-term sustainability of space activities. By sharing knowledge, coordinating efforts, and upholding common standards, we can ensure that space remains a valuable resource for all of humanity, fostering scientific discovery, technological innovation, and peaceful collaboration for generations to come. The next leap forward, innovations on the horizon. The realm of LEO satellites is far from static. Driven by relentless innovation, the future of LEO connectivity promises to be transformative. Imagine a world where internet access from space is faster and seamlessly integrated. Inter-satellite communication using lasers offers higher bandwidth and lower latency. Mega constellations aim to provide global internet coverage, even in remote areas. LEO satellites with advanced sensors will enhance weather forecasting and disaster response. Towards a sustainable space ecosystem. Space sustainability is paramount as we venture into LEO. Managing satellites and mitigating debris ensures long-term viability. Reusable satellite platforms are a promising approach. Designed for multiple deployments, they reduce new launches and debris. Upgradable in orbit, they extend operational life and value. Self-cleaning mechanisms for LEO satellites are under research. Technologies to capture or deflect debris are crucial. International cooperation and clear guidelines are essential. We must steward the space environment responsibly. The LEO revolution, connecting the unconnected, powering the future. From the vast expanse of space, a revolution in connectivity is unfolding, transforming the way we live, work, and connect with the world around us. Low Earth orbit satellites, once a concept confined to science fiction, have emerged as a technological tour de force, bridging the digital divide, powering innovation, and extending the reach of the internet to the farthest corners of our planet. We've journeyed from the basic principles of LEO, understanding their close proximity to Earth, their incredible speeds, and the technological marvels packed within their compact frames, to grasping the profound impact they have on internet connectivity. We've explored the advantages of low latency, enabling near-instantaneous communication, the abundance of bandwidth, capable of handling our data-hungry world, and the global reach of LEO constellations, extending connectivity to even the most remote and underserved communities. The LEO revolution is not merely about providing internet access. It's about empowering individuals, communities, and entire nations with the tools to participate in the global digital economy, access educational resources, receive timely health care, and connect with the world in ways unimaginable just a few decades ago. Balancing innovation with sustainability. As we push the boundaries of LEO technology, we must protect the space environment. Managing the growing number of satellites and mitigating space debris risks are crucial. This requires international cooperation and responsible space stewardship. Clear guidelines for satellite design, operation, and disposal are essential. Investing in debris removal and reusable satellites ensures LEO's long-term viability. The future of LEO satellites is bright, but it depends on sustainable practices.